Welcome back. This is Professor Ridge and today's lesson on section 3.8, Business and Economics Applications. So the first thing we want to talk about in business applications is this break-even analysis. So a lot of times for businesses we want to make sure we know what it takes to break even, at least to recover the money we spent. Okay, so a couple of things that we need to think about is we have our profit revenue. Profit is your revenue minus your costs, and we're going to write them using our function notation. So P of X is our profit function, and R of X is our revenue function, minus C of X will be our cost function to produce X units. So we have a profit function, revenue function, and cost, and we know profit is revenue minus cost. Okay, and our break-even point is where revenues equals cost, so that's where our R of X equals C of X. Now if we were to graph this revenue function y equals R of X and graph the cost function y equals C of X, and basically this break-even point is where those two graphs would intersect each other. Okay, so that's what we're going to be looking for if we graph it. Alright, so let's try one of the homework exercises. Okay, so for each of the following pairs of total cost and total revenue functions, find A, so it's two-parter, A, the total profit function, just the profit function, find P of X. So A, find P of X. And then B, find the break-even point. So let's translate that. We're going to find break-even point, remember, is right here where the two functions are equal to each other. Okay, so for A, we want to find P of X. So remember, P of X is just the revenue minus cost. So that's going to be, so revenue 70x minus cost function is, put that in parentheses because you're going to have to distribute that minus sign. So our profit function will simply be 70x minus 20x minus 500,000. Combine like terms, so we get 50x minus 500,000. Okay, so that's for A. Now for B, we want the break-even point. So we're going to find R of X equals C of X. So R of X is 70x, 20x plus 500. So we want to find, so X could be whatever the units are that we're producing. So if I'm a big TV manufacturer, X could be the number of TVs I make. So $20 would be pretty cheap for a TV, so it's something else. But anyway, or $70 even. So, but you get the idea, hopefully. So the idea is it costs me $20 for each one I produce, plus I have what the plus 500,000, those would be my fixed costs for things like my rent, insurance, anything that doesn't fluctuate based on how many units I sell or make. Okay, so we want to solve this for X to figure out how many units we need to make and sell to break even. So just subtract 20x had a little technical difficulty there, so minus 20x from both sides. So that's 50x equals 500,000. Divide both sides by 50. So x equals x equals 10,000 units, whatever that is. Again, I don't know. Okay, so I would have to produce 10,000 units, produce and sell 10,000 units, and that'll break even. And my profit function is 50x minus 500,000. Okay, let's try number 16. So same thing, find profit. So remember, that's revenue minus cost, which is going to give us 58 x minus, and don't forget to distribute that minus sign, so I'm going to show a little less work here. 58 minus 40 is 18x. Now another way that you can do the break-even point, basically the profit is function. To break even, you're basically saying you're not going to lose money, you're not going to make money. So you can set this equation to 0. So that would be an alternate way to do it. So you can take your profit and set it equal to 0. That would be an alternate way to do it. So of course you could do it the other way, and you'll see you'll get the same result. You'll get to this step, right? So 58x equals 40x plus 8010. You're going to subtract 40x from both sides, and you end up with this equation. Because again, to break even, that means you're not making money, you're not losing money. So your profit would be 0. So if you take your profit function, set it equals 0, you can figure out that you would need to do 445 units to break even, to make no money, but not to lose any money either. Alright, so there you go. Okay, so now the next thing in this section is on the supply and demand curves and finding an equilibrium point. So let's look at that. Okay, so for a demand function, we know that the cheaper the price, the greater the demand. So if we had a low price, the demand may be way up here. And as the price increases, more and more people are going to seek alternatives or just choose not to buy it. So that's the demand curve. And supply works the other way. If the price is real cheap, businesses don't have the incentive to make so much because you're not going to make a lot of money. But as the price goes up, they're going to want to make more and more, so the supply increases. So they have inverse relationships, the supply and demand. So basically, the equilibrium point is, so we go out to the marketplace. So if we have the number of units over here being supplied and demanded, and the price on the bottom. So if we have our demand curve, or in this case a line, and supply line, the intersection point is what's called the equilibrium point. So the market kind of settles into an equilibrium point, right? So as the demand increases, the price goes up, and vice versa. As the supply as the price goes up, the demand decreases. I don't know which way I just said it. So anyway, they have inverse relationships, and eventually the market settles in at this equilibrium point. Okay, so how you find it? Well, you can either graph it or just set the two equations equal to each other and do it algebraically. So let's try one. Okay, so here we have the demand curve is 2000 minus 15p, and again it's a line, that's a linear equation. You notice we're not going to graph it, we're going to solve it algebraically, but the demand curve, so this is our price and this is our quantity. As the price, if it's really cheap, the demand is going to be high, and as the price goes up, the demand curve goes down. And the other way around, for supply, if it's the price is real cheap, there's not going to be many people making the product, and as the price goes up, more and more people will jump into the market to produce more, so the supply will go up. So somewhere we want to reach this equilibrium point where they intersect. So basically that's, you just set these two equations equal to each other to get your equilibrium point. So 2000 minus 15p is our demand. Supply is 740 plus 6p. We're going to solve it, so let's add 15p to both sides. So that's 21p, and let's subtract 740 from both sides. So 2000 minus 740, 1260. Divide both sides by 21. And we get 60. So we'll find an equilibrium point when the price is set at $60, and the supply would be, so now we plug in 60 into either equation. They're equal to each other, so it doesn't matter. Supply, demand is at so if we put in 60, again you can put in either equation because they're going to give you the same answer. So what's that? 900 minus 2000, or from 2000, so that's 1100. So you need to produce demand 1100 units. Okay, so that would be the equilibrium point. So we can write it as point 60, 1100 if we're thinking of the graph. Alright, so that concludes this lesson for section 3.8, and go to my math lab, complete the exercises there, and I'll see you next time.